Good morning, everyone. Thank you for joining EAC's webinar today. My name is Addison Tyne. I am the marketing specialist here at EAC. Today, we will be talking about how you can speed up assembly design and streamline the flow of information from design to manufacturing with PTC's Creo Advanced Assembly extension. We will begin today's session with an introduction of EAC, and then Bill Schlund, our technical account manager and Creo expert, will be taking over. This session is being recorded. Pending any technical difficulties, everyone will receive a replay after the webinar. Please feel free to drop questions in the queue and we will answer them after the presentation. We will have a short survey at the end that will appear once the webinar is over, so stick around for a moment to answer those questions. Our mission is to transform the way companies design, manufacture, connect to, and service their products. We're more than just a value-added reseller for PTC. We've actually been partnered with them for over 20 years with experts in 22 areas of product development. We're located all over the US with our headquarters in Minneapolis, Minnesota. We offer our customers everything they need for product development, from CAD software and simulation software for the full product design process, software for managing service documentation, and software for managing product data. We assist with design and engineering projects and offer webinars and PTC certified training courses for continuous learning. We also implement the industrial Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We also offer our customers Formlabs desktop SLA printers at packages starting as low as $34.99. We try to make sure you remember that EAC is the company you need to partner with to get all the technology you need at the forefront to make your team successful. Without further ado, I will go ahead and hand things off to Bill so we can get started.
Thanks, Addie. Good morning, good afternoon, everybody. My name is Bill Schlund, and I'll be going through some of the capabilities of the Advanced Assembly Extension. The acronym is AAX, if you've heard that before. But we'll talk about some of its capabilities, kind of make it unique in the realm of assembly capabilities. One of the things I have here, and I got this off of the knowledge base, but on the column here in the middle is a listing of all the capabilities in regular assembly mode. And then in the right column, we'll start to check off the things that are unique to advanced assembly. I'm not going to read through all of these. This is being recorded, so you can go through the recording and stop this and read these as you need. But as you can see, there's a lot of capabilities just in core Creo, just in basic functionality. But then we start to see some other things here that are in advanced assembly. And that has to do with a lot of times working with large assemblies, being able to manipulate geometry in certain ways, maybe creating kind of configurators or things like that. So I'm going to be going through some of those capabilities today, but kind of highlighting on the unique capabilities of the Advanced Assembly Extension. So as I mentioned before, most people, when they think about the Advanced Assembly Extension, they think about large assemblies and working with lots of data and being able to get some tools to help you with top-down design. So I'm going to go through an example of that just so we can kind of see some of those capabilities. And the thing is that I'm going to kind of bounce back and forth. I'll do a little bit of PowerPoint, tell you concept, and then we'll go and show it in using the software here. So let's talk a little bit about large assemblies. I'm going to pop up an assembly here, and I'm practicing in this example kind of top-down design. So right now I just have the base assembly, and I've created a couple of empty assemblies here. So I can just start creating the basic sub-assemblies that I'm going to have for my assembly. I'm making a desktop computer in this particular example, but I have a sub-assembly here for the chassis, so components that go with the chassis I can start putting in there, and then maybe for a power supply, and then maybe a motherboard, and things like that, things that make up a computer. But the nice thing is I can start to put this whole structure together and just assemble them all together without having any geometry at all. So I'm kind of setting up the architecture of what I want this assembly to look like. So one of the things I'm going to do is talk a little bit about what AAX allows you to do in this particular example. So the first thing you might want to do is create a skeleton. And a skeleton can be a series of datums. So it could be datum planes, axes, points, coordinate systems, things that can kind of organize where we want certain components or sub-assemblies to go, and to kind of sketch out an envelope that we might want this assembly to be enclosed in. So first of all, we'll go through and we'll say, let's create. And we'll come over here and we'll say, let's create a skeleton part. And we'll give it the default name here. And right away, when it puts in the skeleton part, you notice that it didn't put it after the other sub-assemblies that I put in here, put it at the very top. So the skeleton part sits at the very top of the assembly. And because everybody else is, in theory, going to reference information inside our skeleton part. And the skeleton part is just a regular part, right? Just has some datum planes and coordinate systems and things like that. We can obviously have different types of layers and views and things associated with our skeleton part as well. So there's a config option. Well, let me show you one other thing, and then I'll show you something kind of interesting. Let's show you another capability of advanced assembly. Now, we can always assemble parts in, right? But there's a new one here called include. And it kind of goes in the same vein as I've just been creating empty sub-assemblies, right, to hold stuff eventually. In this case, with include, I'm going to go in and grab an assembly that's existing. So here's a graphics card, and I just double-click on that, and it automatically added it to my assembly. You notice I didn't have to do mate, align, anything like that. It included it here. You notice it's sort of grayed out. That's an indication back to me that this is being brought in as an included part. So it's not assembled yet, but it does have all the components, right? So I can bring in also existing assemblies, place those, and then later on, when I need to place them exactly in the assembly where I need them, they're already here for me. So we've got a couple of assemblies here. We've got, this graphics card that we brought in. You can have multiple skeletons, right? There's a config option. You can say allow multiple skeletons. And what I'm going to do here is bring in another one, but I'm not going to make one. So skeleton part is a .prt file. Creo looks at it as being a little bit unique compared to regular parts. But so what I'm going to do is assemble in an existing skeleton part. So a lot of people don't use this technique, but it's actually pretty good. I'm going to come in and say, let's go and find our skeleton part. And here I have sort of a generic computer skeleton part. And you can see it has some geometry associated with it. I'm going to say, let's place him in there. And so now I can place this skeleton part any place in the assembly where I think it could be useful. In this particular example, I'm just going to place it right at the original coordinate system at 0, 0, 0. So now I brought in a second skeleton, and you notice that it placed it after the first, but ahead of everybody else in the assembly, ahead of all the other assembly components and sub-assemblies that I have here. So one of the things I'll do here, I'll kind of, let's set this guy up so we can kind of see through him a little bit. So I'm going to say, let's set the style. And we'll just make it so we just don't see this huge block here, but we'll kind of display it in wireframe mode. So now we have our component here. Let's turn on some planes, turn off the axes. So my skeleton part, my generic one that I brought in, has an envelope here of the desktop computer. So everything that I create for it will be inside of this box. I have a datum plane here for the power supply. I have another datum plane over here for the graphics card. In fact, now that I have kind of an envelope, an idea of how big this desktop's going to be, I can go over here to my graphics card and I can say, let's edit definition. Let's place this guy in our assembly. And we can see his representation up here. And I'm just going to kind of pop him up here and flip him around. And then we'll maybe move him over a little bit and then place him maybe back here in our computer. So I'm just placing him right now. I'm not going to put him in exactly, but you can see that it was very easy for me just to grab that assembly that I had included before, and now he's placed in our envelope part that we see here. Now, one of the other things with the capabilities of the advanced assembly extensions, we can control who can reference what when we're starting to build our assembly. Let me give you an example of that. So it's called reference control. I'm going to go over here to our chassis, and I actually have a tray in here right at the bottom of our chassis, right? So this is going to be part of the chassis, but it's sitting there. Now what I want to do is create some information for the power supply, right? That was another sub-assembly that I put in here. So I'm going to say, let's activate that. And I want to create, let's say, our power supply. So let's cancel out of here for a second. We're going to activate this guy. There he is. So we're going to say, let's extrude. And we'll say, let's extrude from our top plane here. And we'll say, let's make a rectangle. So this is our power supply. I'll say, okay. And now we can extrude this up. And I'm going to say, let's extrude it up. And we could say, right mouse button, direction. Let's keep it going to this direction. But what I can do is include this up. I could say all the way up to here. What this is doing for me, though, is it's allowing me to build geometry here in our assembly here, but it will only let me, in this particular case, I have it set up so it'll only reference skeleton parts or skeleton geometry. It won't allow me to access or reference any other parts. So that's keeping me from kind of going out of scope. So what it allows me to do, let's kind of take a look at this assembly for a second. It's our power supply assembly. I'm just going to open them up to show you where that is. But it's under prepare. It's right down here where we have reference control. And this is where we can say what we want our parts to reference. So in this case, I'm saying only reference skeleton geometry. So if I'm creating anything, it can only reference the skeleton. It can't reference other parts that are in the assembly. That's keeping us from doing parent-child relationships outside of the assembly. Or I could say just components inside the assembly, or reference absolutely everything, right? Which is the default values. So these are kind of the things that we can set up for reference control to allow us to really control where the components are referencing the information. So let's move on to our next example. And we're going to talk a little bit about process for assemblies. Now, this is a new module. It came out in actually Rep 17, but it's one that not a lot of people know about. It allows us to create assembly and disassembly steps using an existing Creo assembly. So let's kind of take a look at those capabilities. I'll kind of erase this stuff out of memory. So I'm going to call up an assembly here. And what I want to do is kind of go over the capabilities of process for assembly. So the first thing I'm going to do is say, this one is already completed. So I'm going to say, let's set the step to step number 1. And now I can play through the different steps, in this case, of assembly. So the first step is here. I could say, let's go to the next one. So we're bringing in the motor. Now we're bringing in a shaft and a housing. The next step is then we bring in the impeller. Then we bring in another component. This isn't actually even part of the assembly, but this is some tooling that we need to support the impeller as we assemble it onto the motor shaft. And then we disassemble that, and then we add in the housing, and then we add in some clips that go on to the shaft, holding it in place. So these are the different steps that we've created using this process for assemblies. The next thing I want to take a look at is we can create drawings, obviously, from each one of these steps. So I'm going to say, let's call up our drawing here. So if we look at the very first sheet, it's highlighting and giving us a bill of materials of all the different steps we have, the different times that are associated with each step. So every time we create a step, we can say how long it takes. And then we can even associate a cost with each step. So it can total all of that up at the end. But then again, we'll see the representations. What we'll see is any new components are being brought in a different color than existing components. Since this motor is the first component, it's coming in this green color. Again, it's kind of to help accentuate the new components that are being added to or disassembled from an existing step. And we don't have to do that, right? It's just an option. Here we can see now we're adding in the housing. So here you can see that the motor is kind of dashed line representation. We can still see kind of solid lines here for bringing in the shaft. And then the next step. So we're seeing each step as they've been created. And then our final step here. So it's very easy to create these. Each step we can just say, place it on sheet 1, then take step 2, place it on sheet 2, and so on and so forth. We can generate all these steps in a drawing format really, really quickly. Let's go and just take a quick look at how we would create some of these steps. So I'm going to say, let's close this guy out. I'm going to open up an assembly here, let's say. I think we can find one up here. Let's call up assembly 1 here. So what we would do is we'd say, let's create a new step. And this is going to be an assembly step. So we'll say done. And then what do we want to include? We want to include this part in that assembly step. We'll say okay. And then we can start to go in and say we want to put in some other information. We can create an explode state. We can say the time estimate, right? So how long does it take to bring this component in? And then we can also include in, you notice it's kind of using the old-fashioned menus here. And then we can also go in and say, what's the cost estimate for that? And then put that in as well. So that's how we go about defining each one of these steps as we go about creating our existing, either assembly or disassembly steps. And as I mentioned before, we can bring in additional models if we need that to support different steps, whether we're putting things together or taking those apart. So again, this is not a widely known module, but it's all part of the advanced assembly extension to allow us to create these assembly steps and then deliver those out onto the shop floor. As a matter of fact, this can be also used in Creo view. We can save this as a Creo view file, and each one of those steps is in that Creo view model, and we can click through them that way. That way it's really easy for us to put it onto the shop floor for visualization and for use. So let's go on to our next step here. I'll talk a little bit about Pro Program. Now, in regular assembly, we have Pro Program for parts, but in advanced assembly extension, we have Pro Program for assemblies, and then we can also leverage Pro Notebook, which used to be called Pro Layout back in the old days. But we'll go through an example of both of these, and you can kind of see how those work. So I'm going to say, let's call up an example here. I'll say, let's grab this guy. So you have an assembly, and this is for an elevator, right? So this is what you would see against the wall. This is the electrical box that's behind it. But we have this part already set up for using Pro Program. So one of the things that I'll do is, in order to activate that, you just say regenerate. And we can say here, we want to enter in some new values instead of keeping it exactly the same. So it's going to prompt me for different aspects of this assembly. And I'm going to answer the questions. And by the way that I answer the questions, it will rebuild this assembly to fulfill the things that I ask it. So we'll say, these are the different things. So the number of floors, different types of buttons, things like that. So I'm going to say, let's do all of these. So I'm checking off all of these. It's going to ask me questions about each one of these types of information that have to do with our assembly here. So the first one says, how many floors do you have? Will this elevator serve? So I could say, let's pick an odd number. Let's say like 21. The next one is, what style of button do you want? Do you want square buttons like you see here? Do you want round buttons, oval buttons? So I'll say, I don't know, let's make round buttons. And it says, do you want to have an upgraded design? This is sort of a plain design, what we see here. So yeah, let's do upgraded. Do you want to have a top cutout like we see right here? I'm going to say no, I don't want one. Do you want a cutout for an emergency phone? Yes, I do. And then do you want a no smoking sign? And I'll say yes to that as well. So here's our new design. As you can see, it's updated everything. And we can see that, the box is updated as well. But again, there's some logic in here. If we pick an odd number, it rounds it up to the next even number so that we have that. Obviously, you've seen in some elevators, you'll have like a blank button in there because you have an odd number of floors. That's exactly what we're doing here. But again, just by entering in different values, we can derive a variety of different types of elevator panels. So my next example is using that same idea, but we're going to drive it using a notebook. So let's take a look at that for a second. And I'm going to say, let's call up our layout that drives this. So here's the notebook page. And again, instead of it asking me questions though, here I fill in the answers on this page and then pushes that information into the assembly. So let's call up that assembly as well. So here's our assembly of our hydraulic cylinder. So if we go back to our notebook page, again, you can kind of see that this lends itself to the concept of a configurator where we're inputting in a lot of information. Somebody could be sitting here at a call desk and getting information from a customer, inputting it, and it'll automatically create the assembly. And then obviously if there's drawings and anything else associated with it, those are updated as well. So here are the different types of things that we can change in respect to our hydraulic cylinder. The first one is mounting style. This one, you notice, has feet on it. So I'm going to say, maybe let's change that. And we'll say, let's change it to a style that doesn't have feet, right? So that's a 50 style version. Also, here's the stroke. It's an 8-inch stroke that we have on this one. We're going to say, let's change that. And let's make it maybe like 15 inches. One of the things this does, kind of a little sidelight, is that it allows us to go in here and change this as an intelligent part number, which is kind of nice as well. So if I say regenerate, update this, the part number has changed. So now it's a 50 series with a 15-inch stroke. So that's not an AAX advanced assembly extension, but it's something you can do in Creo to make intelligent part numbers. It's actually pulling some of these parameters out, in fact, a lot of them, and putting them into the part number here. But if we go back and say, let's take a look at our assembly now, and we update him, now we have hydraulic without any feet and 15-inch stroke. So again, this is some of the capabilities of using a notebook along with program for assemblies. So next step down here, we'll move on, is merge and inheritance. So this is actually kind of a really cool technique and capability where we can build a version of a part and customize it the way we want, and it still keeps the capabilities and the inherited change ability of the part. So let's call something up here and we'll take a look at that. So I'm going to call up a part here. And I actually called it up in an assembly. So the part is assembled into an assembly. And what I want to do is make maybe a rough cast version of this. So you notice that there's some machined features on here, some holes and some chamfers and things like that. I want to see this part before it was machined. So I can have two versions of it, pre-machined and after. So to do something like that, I'm just going to go in here and say, let's create a brand new part. And we'll say, let's make this, let's call it like just our rough casting. And we'll just kind of assemble it at the default coordinate system where this guy is. So now we have two parts, right? We have the original part, which is machined, and then we have an empty part. So this is where we would go in and start to do the merge inheritance. So I want to show you the difference between just merging parts and then using the merge inheritance. So I'm going to activate him, right? So I'm activating an empty part. And I'm going to say, now let's put the geometry of this part into the empty part. So over here, I can use merge inheritance. And if I just use a regular merge feature, it's saying, what do you want to merge in to this empty part, right? The empty part has nothing in there, right? Except a couple of coordinates or coordinate system and some planes. I'm going to say, let's go in and use this geometry. Now if I say okay, it brings in a merge feature, right? So it brings all that geometry in, but as a single feature, like bringing in a step or an IGES file, which isn't going to help me a lot in what I want to do. So I'm going to say, let's undo this. And instead, I'm going to do the same approach, but in this case, when I say merge inheritance, and I pick the part that I want to merge in, I'm going to pick this button right here, which is called toggle on inheritance. When I do that, and I say OK, it brings it in, but it brings in all the features, right? So this is important because now I can start to work with these individual features. Now that he's my rough casting part, let's open them up. We can take a look at it real quickly here. So we have all the features here, but I want to make it look like the casting when we first get it. So I'm going to say, let's take some of this information and some of these machine features, and let's turn them off. And then we could say, let's take the whole, and we'll shut him off as well. So here's sort of our rough casting. Now, one of the things that I can do with this is this top face up here is a machine face, right? And so it is probably machined down to this. So I want to add some material on here. One of the things I can do is I can take this extrude and I can change the value here. So right now you'll notice it's 6, and I could add, maybe 50 thousandths onto it. The thing is, if I change any of these dimensions in our inherited part, they will stay at that dimension. So if I change this to 6.05, in the original model, I could change that to 7 or to 8, and this will stay at 605. So whatever things I change here, and it doesn't just have to be dimensions, right? As we saw with our list here, they can be dimensions, they could be features, geometric tolerances, parameters, notes, surface finishes, all those types of things. So if I change any of those here, they stay that way, but everything else will update as the other model changes. So for something like this, I really wouldn't change this number, but what I might do is come in maybe under flex modeling and say, let's move this face up and just add a little bit of a, and I'd put in obviously a hard number there, but now I've added a little bit of material to that there to represent the original casting, and then we're going to machine off the top face before we drill the hole. So now we have our rough casting here, and if I go back to our assembly that we have here, let's hide the casting here for a second. Here we have our part. Now if I want to go in and make any changes to him, I could say, let's activate this guy. We'll look at some of his features. And we can say, let's make some changes. We'll make the overall thickness, maybe make it thicker there. We could say this offset distance here, we'll increase that. And really what I'm going to show you is that as we change things here, we're also going to have our model update. And maybe this guy over here, we could change this. We'll make it smaller. We'll say 5. And when we say that we're finished with this, we want to regenerate it. This is our new version of our machine version. And if we go back to our part over here, and we update him, you notice that he is updated as well. We still have that material that I added on the top, but everything else has updated. So the things I change here will be fixed here, but everything else will update. So this is really a cool technique to allow us to have models kind of update and have certain parts of them not update, depending on what we want to do. Here I'm using an example of a casting, but there's a lot of other ways that we can use this as well. So, and finally, last thing I want to talk about is interchange assemblies. So in regular assembly, we can interchange parts. We can swap one part out for another part, sort of like you can with family tables. In this case, I'm going to call up another assembly, and we'll say, let's call up, let's just look for assemblies here. We'll call up our security camera. So here we have a security camera, and it's made up of a variety of different types of sub-assemblies and components and things like that. There's a knob assembly here that I might want to swap out with a different type of knob. So what I've created is an interchange assembly. And we'll call that up real quickly so you can kind of take a look at it. But here's our knob interchange assembly. So we have the knob that we have in there now, the subassembly of that, and then we have another subassembly of a different type of knob. And I can continue putting in other types of subassemblies of different types of knobs. And what it means is I can swap any one of these out for any other one. So if we go back to our assembly here, I could take our knob assembly and just say I want to replace him. And I want to replace him with this interchange assembly that we have here. Say okay, okay, and it swaps them out with the newer version, right? Really easy to do. All I needed to do is set up this interchange assemblies. I can swap out then any subassembly with any other subassembly that's in that group. So that kind of running out of time, that does bring us to the end of the things that I wanted to highlight there. But I'm going to turn this back to Addison. And as you mentioned before, we will, if you want to stay on, have some questions in regards to what you thought of this.
Right. Thank you so much, everyone, for joining today for the webinar. I do want to let everyone know that we have extended our promotion for 50% off eligible Creo extensions. I will provide a link to this promotion in the follow-up email being sent out this afternoon, along with the replay for this webinar. I'll also include a link to the webinar for next week, which will be on Creo 7 and all the features and benefits included in that. Thanks again, everyone, and we hope to see you next week and on future EAC webinars. Have a great rest of your day.